You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In cloud computing environments, storage access protocols determine how compute instances interact with various storage services. These protocols act as translators between applications and the underlying storage hardware or service. Depending on the storage type, whether it is block level, file level, or object level, different protocols are used to ensure efficient, secure, and reliable access. File protocols such as NFS and CIFS allow shared access to directories and files across systems, while block protocols such as iSCSI, Fibre Channel, and NVMe-oF fabrics provide low-level, high-performance access to raw storage blocks. Within the Cloud Plus certification, understanding these protocols is a key competency in deployment design and network integration. The choice of storage protocol has a direct effect on how a system performs and how compatible it is with various operating systems and application workloads. For example, a protocol that excels in throughput may not offer the same degree of flexibility or OS support as a more generic alternative. Likewise, some protocols are better suited to high-speed internal networks, while others work best in distributed, cross-platform environments. The exam often presents protocol use cases or troubleshooting scenarios that require a firm understanding of each protocol's strengths, limitations, and configuration options. Selecting the correct protocol is often the foundation for achieving performance, compliance, and architectural alignment. The Network File System, or NFS, is a file-level storage protocol that is most commonly associated with Unix and Linux environments. NFS enables client systems to mount remote file systems and interact with them as though they were local directories. It operates over standard TCP/IP networks and allows for shared file access by multiple clients. Within the cloud, NFS is commonly used in shared storage configurations and network-attached storage deployments. Candidates must understand how to configure and troubleshoot NFS shares in environments that require concurrent access to data by Linux-based virtual machines. The Common Internet File System, or CIFS, is a protocol designed for Windows environments and is now more commonly referred to under the broader SMB protocol suite. CIFS allows Windows systems to share files, printers, and named pipes across a network. It is deeply integrated with Microsoft technologies, including Active Directory, and is frequently used in corporate environments to manage group shares and legacy application access. Cloud environments that include Windows-based virtual machines often use CIFS to provide seamless access to shared folders. Candidates should know how to configure and secure CIFS shares for Windows compatibility. iSCSI, which stands for Internet Small Computer Systems Interface, is a block-level storage protocol that transmits SCSI commands over IP networks. Unlike file-level protocols, iSCSI makes remote storage appear to the operating system as if it were a locally attached disk. It is widely used in both cloud and on-premises environments for scenarios where performance and flexibility are required. For example, iSCSI is often employed in storage area networks and virtual machine storage design. Within the context of this certification, you'll need to understand how iSCSI is provisioned, secured, and optimized for persistent block storage. Fibre Channel, or FC, is a dedicated block storage protocol that operates over high-speed network fabrics separate from general-purpose Ethernet networks. It uses specialized hardware such as host bus adapters and fiber channel switches to deliver ultra-low latency and high reliability. FC is most commonly deployed in enterprise data centers and high-performance environments where predictable throughput is essential. For the Cloud Plus exam, candidates may be asked to determine when Fibre Channel is a better fit than IP-based alternatives like iSCSI, especially in hybrid cloud or co-located storage environments that emphasize speed and fault isolation. NVMe over fabrics, abbreviated as NVMe-oF, is a modern block storage protocol designed to extend the high-speed capabilities of NVMe solid-state drives across storage networks. It enables parallelized access and minimizes latency by allowing applications to communicate directly with storage devices over network fabrics. NVMe over Fabrics supports both RDMA and Fibre Channel transports, making it suitable for large-scale performance workloads that demand extreme throughput and responsiveness. Within this credential, understanding NVMe-oF as a next-generation protocol option is essential for aligning storage choices with the performance needs of cutting-edge applications. It is critical to distinguish between file protocols and block protocols when planning a cloud deployment. File-level protocols, such as NFS and CIFS, offer shared access to files and directories and are typically easier to configure in multi-user or collaborative environments. Block-level protocols like iSCSI, Fibre Channel, and NVMe over Fabrics provide direct access to raw storage volumes and allow the operating system to manage file systems and partitions. The choice depends on workload requirements, performance expectations, and administrative preferences. This certification includes identifying which access method aligns best with the structure and function of a given application. Connecting to storage using these protocols involves specific mounting or discovery processes. File-level protocols typically require the creation of mount points, where remote directories are integrated into the local file system. Block-level protocols use logical unit numbers, or LUNs, that must be discovered and mapped to a host. In both cases, access control lists, authentication settings, and firewall rules are required to establish and maintain secure connections. The exam may test your ability to diagnose a failed mount operation or a permission error by recognizing the configuration gaps that prevent successful protocol usage. Storage protocols must be secured to prevent unauthorized access and data breaches. For example, iSCSI and NFS traffic can be intercepted if sent over unsecured networks, especially when used in public or hybrid cloud environments. Encrypting data in transit is strongly recommended and may be required by organizational policy or regulatory standards. Firewalls should be configured to allow traffic only from known hosts, and access to storage interfaces should be tightly controlled. Candidates must demonstrate an understanding of how to secure each protocol, including applying encryption, port restrictions, and client-side protections. Each protocol exhibits unique performance characteristics that influence how well it fits certain applications. Fibre Channel and NVMe over Fabrics provide the lowest latency and highest throughput, making them ideal for performance-sensitive applications like transaction processing or real-time analytics. NFS and CIFS offer easier configuration and broad compatibility, but come with additional overhead that can reduce performance. iSCSI performance is highly variable and depends on network quality, packet loss, and latency. For this certification, understanding the performance profile of each protocol helps guide protocol selection and configuration strategies. Cloud providers support these storage protocols in different ways, depending on the type of service and the level of control provided. For file storage, services like Amazon EFS and Azure Files provide managed NFS or CIFS access. Block storage services like Amazon EBS operate using iSCSI behind the scenes, though users may not always have visibility into the protocol layer. Hybrid and enterprise environments may allow Fibre Channel or NVMe over Fabrics integration. The exam may include questions about which protocol is available for a specific cloud-native service, or how protocol support varies across providers. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Each of the storage access protocols we have discussed operates over a defined set of network ports. These port numbers are essential for establishing connections between clients and storage services. For example, NFS typically uses TCP or UDP port 2049. CIFS, which aligns with the SMB protocol suite, operates over TCP port 445. iSCSI commonly uses TCP port 3260. If these ports are not allowed through firewalls or security groups, the connection between the compute instance and the storage device will fail. For the exam, it is important to understand not only the port numbers but also how to troubleshoot connectivity issues that arise when these ports are blocked. Authentication and permission management vary significantly between storage access protocols. Some protocols allow for anonymous access by default, which is generally insecure and must be restricted. CIFS often integrates with domain-level access control using Active Directory or other centralized authentication systems. iSCSI may use Challenge Handshake Authentication Protocol or require that initiator IP addresses be explicitly authorized. Access control lists, user credentials, and integration with identity management systems must all be considered. Candidates should be prepared to configure secure access for each protocol and recognize misconfigurations that could lead to unauthorized access or service disruption. Many enterprise-grade storage systems offer multi-protocol support, meaning they can provide access to the same data using both NFS and CIFS protocols. This is particularly useful in environments where Linux and Windows clients need to share the same data. However, offering multi-protocol access introduces complexity around file locking, permissions, and character encoding. The file system must be compatible with both protocols, and administrators must ensure consistency in access control and user identity mapping. On the exam, you may be presented with a mixed operating system scenario and asked to determine the appropriate protocol configuration or troubleshoot inconsistencies caused by dual protocol access. Protocol overhead and latency should be considered carefully when choosing a storage solution. File protocols like NFS and CIFS introduce higher overhead due to additional metadata operations, user permission checks, and file-level abstraction layers. This added complexity can result in increased latency, particularly in high-frequency read-write environments. Block-level protocols such as iSCSI and Fibre Channel bypass much of this overhead by interacting directly with the storage blocks, resulting in faster response times. The Cloud Plus certification requires you to evaluate protocol overhead and latency in the context of application performance requirements and select the protocol that best aligns with sensitivity to delay. Disaster recovery features vary significantly by storage protocol. Block-level storage is often snapshot-capable, meaning that an entire volume can be captured at a point in time for recovery purposes. File-level protocols may support versioning, where individual files can be restored to previous states. Additionally, replication methods differ by protocol. Some allow for target-based replication, while others require more advanced replication technologies. In cloud environments, the ability to replicate mount points, perform failovers, and meet recovery point objectives depends in part on the storage protocol in use. The exam will likely include scenarios where selecting a protocol that meets recovery requirements is critical. Monitoring usage and performance metrics across storage protocols is an essential operational practice. Metrics such as active session count, read and write throughput, and latency help assess whether the current storage configuration is adequate. Error logs specific to the protocol, such as failed mount attempts or authentication errors, can point to configuration problems. Cloud providers often supply native monitoring tools or dashboards that visualize protocol usage. Candidates must understand how to interpret these metrics and logs and how to configure alerts based on performance thresholds or failure indicators to maintain service availability. Operating system compatibility is not guaranteed for every protocol and must be verified during the planning phase of a deployment. Some operating systems require kernel modules or specific packages to support protocols like NFS version 4 or iSCSI initiators. Other systems may support older versions of a protocol but lack newer features or encryption standards. Additionally, Default security settings or networking behavior may interfere with protocol operation. As a certified professional, you must ensure that all planned systems are capable of interacting with the selected storage protocol, and that any compatibility issues are addressed before production deployment. To bring these considerations together, it is essential to have a clear strategy for protocol selection. Each storage protocol comes with its own benefits and trade-offs. File-level protocols are ideal for shared access and compatibility, but introduce overhead. Block-level protocols provide low latency and high performance, but require more configuration. Compatibility with the operating system, security model, and performance expectations all influence the selection. This certification includes making protocol decisions based on use case alignment, configuration requirements, and operational support. Your ability to choose the correct protocol under exam conditions is a key competency. When designing cloud infrastructure, protocol selection is one of the earliest and most influential choices you will make. It affects not only technical performance but also operational behavior, compatibility, and even licensing models. Storage protocols must be understood in the context of the entire stack, from network access and firewall rules to file system support and application needs. This certification ensures that you are capable of making informed protocol decisions that support reliable, secure, and efficient access to cloud-based storage resources. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.